Hello, welcome back to the shrine. What we got here today is a Crosse technology TX144W anemometer, and as you can see it has seen better days. So this propeller on the top is kind of getting stuck, and even when it's spinning it's making this funky sound. So imagine this piece belongs to a weather station, and this is up on the roof. The roof acts like an amplifier for like a piano. So when this thing is grinding and it's making its noise, the entire house just echoes with it. It's really annoying. So I went up to investigate what is going on. So you can see clearly there is a run out. This entire upper propeller section is wiggly. I don't think it's supposed to be like that. This unit is about 1 year old. It is placed on the top of a house in the Midwest, somewhere in the Rust Belt, and so it's gonna see 4 seasons at its best. So we're gonna go tear it apart and investigate what is happening. So this bottom part screws off like that, and you can see it's got these holes on the bottom to let the condensation out from the battery box, and it's got spider webs inside. There are the batteries. These are LR14 size, 2 of them. I can see some corrosion here on this lower part. Again, this is after 1 year of use. No corrosion on the upper part. So this is down, this is up. If there's condensation, it can settle on this plate. It's not really reassuring that after 1 year of use, it's already not a good one. Now, this was an expensive unit. This was like $80. So let's take this upper section off. Looks like there's a screw. See what's beneath. There you go. So there's more spider webs inside. There's a nice little worm for your tequila. So this is the shaft. You can see that the shaft has excessive run out, and it looks like there's some sort of a bushing, but the bushing is disconnected from the housing. Just get a couple more screwdrivers to complete the job. So a lot of dust and a lot of fret wear. So let's get the rotor out, which pops out just like that. And look at that, what a surprise. Interestingly, it's got bearings, ball bearings. Look at that, little bar bearings. And they are shielded. And then this lower one here probably got too much condensation, so it's in pieces. Can you see that? There's the shield from the bearing, and the outer cage of the bearing is completely stuck shut. It's probably a rusted shut. So this is the rotor part, and it's got a little magnet on it. Right, there's a magnet. So there's one magnet on one side, and as it got loose, can you see how it turned and rubbed on this top surface? That was probably making that scary noise. I can see little spiders moving around. Looks like I intruded into their house. So there's the magnet, and there's a switch here. This is one of these encapsulated glass reed switches, so when I pass the magnet I can hear the clicking. So that is the switch that gives out the pulses. Every time this goes around, it gives a pulse to the electronics. Wow, this is really dirty, and there are too many spiders inside. I didn't sign up for this. I'm gonna go and dust it off. Looks like there are 2 more screws here that we can remove. Just always use the proper tools. There's one more label on the other side. Looks like these guys were paid by the number of labels that they can slap on. So there you have it. Not much, just some connections to the battery. There's a red cable, and then there's an interconnect on this side. You know, they didn't make like one plate that would go to both sides. They use this piece of wire to connect between the plates, so that completes the circuit for the battery. And then in here we have basically these 2 battery cables tying up to the PCB. The PCB has a brain box. It's got a crystal here, some capacitors, bunch of passives, and it's also hooked up to this reed sensor. Again, this is the reed sensor that is sensing the speed of the anemometer, and we got some kind of spring thing here. I'm not sure what this exactly does. It looks like if I pluck it, it will keep vibrating. So this might be a earthquake sensor, something along those lines. So it looks like these lures just pop out. So there's one on this side. There you go. So it pops out like so. And now this bottom part comes out, and that's pretty much it. So you have a top bearing here, and I'm pretty sure the bearings just press in, and then this lower one. So let's see the fit. So as you can see, it completely wore out the housing. At this point, this is pretty much a piece of junk that you can just get rid of. You're not gonna be able to buy anything for this. So this is basically the pinnacle of the throwaway society. That's it. The electronics works. The plastic is not cracked, but because the way these bearings are constructed and installed, you know, they wore out the housing. You can see the housing is completely worn. Both of the bearings are loose in a housing. So this is trash. So one might think, what could have been done to prevent these bearings from failing? And one of the things that someone can try is install a sealed bearing. These bearings have shields. You can see the top one is still spinning, and then the bottom one is frozen shut. Oh, look at that, it just pops out like so. Huh. So it had a press fit with this bearing carrier, but you can see it just pops out. Here's the shaft. You can see there's not much to it, and this is not a spacer, it's a part of the shaft. The ends of the shaft are machined, and you can see it's properly rusted under the bearings, so there's a little slip fit. So this indicates that there's a moisture, and here are the bearings. The bearings are the same size. They both 6 by 3 millimeters in diameter and 2.5 millimeter wide. So I looked into my drawer and I found similar bearings. Now this is 6 by 2 by 3, So it's not gonna fit because the shaft size is 2 millimeters instead of 3. And then I have a big one here. This has an 8 millimeter outside diameter, so that's not gonna fit. So I kept going in my drawer, and this is one of my first Outrunner motors from 2005, 6, 7. And the shaft size on these are all ubiquitous, you know, it's 3 millimeters, and then this bearing is 7 millimeters. And I have another one here, this motor, this also has a 3 millimeter shaft, and then it appears that the bearing on this one is 7 millimeters. So none of them is a good fit. So begs the question, what should I do with this? You know, one option would be to put larger bearings in. I might end up just increasing the size and basically using a larger size bearing. So that's the plan right now. And just like that, the bearings are harvested. Let's see what their size is. So it's 7 millimeters by 3 by 3. So it's a little larger one, but if I can bore this up, that would be a great fit. I'm just gonna hand ream these. So you can see this hole is so wallered that the 1/4 inch just passes right through. So there's a 1/4 inch. This is 17/64, which would be 6.7 millimeter. And I'm just gonna go and gently apply it. As gentle as I can do it. So there you have it. I was trying to look for a 4 flute, but I only have the 2 flute version of this. This is 17/64. And then this is a 7 millimeter. So there you have it. Now I can press the bearing in, and it looks like it's a good fit. Again, the 1/4 inch just slides right in. I think that's going to be plenty of depth for the bearing to sit in. Let's see if it fits. Look at that. That's a good fit. First I'm gonna go and get rid of these rust spots from the shaft. You can see both sides are rusted. So just use this Scotch-Brite, clean it up. The bearings have pretty loose fit with the shaft, as you can see. It slides on and it wobbles. And it's 3 millimeters, but still. So I'm just gonna go and administer some of this Loctite retaining compound between the shaft and the bearings. There you have it. Now I can install the shaft into the housing, but before doing so I'm going to put some of the retaining compound on the outside of the bearings. Hopefully that will help retaining this. There you go. A couple days later, the assembly is complete. A couple notes here: when I spin it fast, I can feel the whole thing shaking and rattling because this is not balanced. You see, this is the rotor, and it's got a magnet on one end, and then there's nothing on the other side. So the weight of the magnet will throw this balance off. I don't like it. I'd rather have 2 magnets in balanced, or like 1 magnet and 1 piece of steel. so it will be balanced, but looks like that wasn't a problem for the designers. No, it's got a fairly big vane here, so it's, I don't know how fast it's gonna spin. I also added a gasket here. Can you see this rubber gasket? So there was like a ledge, and I cut a piece of rubber gasket so that when I put this vane on, there's gonna be a nominal little gap here, but it would not allow the spiders hopefully to crawl in and then nest inside this cavity here. I want to put some lube on these bearings, so I've got this chain lube, and I've chosen this because hopefully it will stick and cling onto the bearing. Just a little bit. There you go. That's all it needs. Hopefully that lube is going to percolate through and then lubricate the bottom bearing too. So at this point I can just go and assemble the whole thing. There's not much to it. But here's a trick for you youngsters. So can you see there are 4 screws on the bottom there, and I need to put 2 more in, and then if you're trying to do it, it will fall off. So here's a trick. You can put a little magnet on the end of the screwdriver, and then it's gonna hold the screw like so, so that when you go in like that, you see you can put the screw in easily. So here's another one. See that? How nicely it holds it. So then you can just position it in, and Bob's your auntie. There you have it. Today's trick. Look at this. Nothing left here. Just the 2 busted bearings, some plastic, and a couple of dead spiders. But otherwise, it's all put back together. The last thing I need to add is the vane. So it's got a D shaft, and this goes in one way only. And then when I spin this, you can hear the clicking inside. Can you hear the clicking? So that is the reed switch inside turning on and off. So there are 2 new batteries. I can install those, and then we can go and check out if it's working. Uh-oh. This is the bottom part, and there's water sloshing inside, which tells me it's not really good. The water is not coming out anywhere, but there's definitely water inside. I'm just gonna leave it as is. Let's see if it works. Maybe this way. There you go. So it looks like the sensor is on. It's got 5 bars and it's showing something, but it's not instantaneous. I think what happens is this guy collects data and it beams the data every once in a while. As you can see, it's on 0 right now, but after a while it's gonna go up to a certain speed if I keep spinning this thing. There you go. So 4 miles an hour. So that is going to be a wrap. I appreciate your time. I hope you enjoyed the video. Let me know your thoughts in the comments down below, and don't forget to subscribe to see what I work on next. See you next time. Bye. It works. Come on. Come on, show me the wind speed. There you go. Good boy.